this week in drought-stricken California. This one was really sad. Dying and starving sea lion pups are stranded on the California coast. I was down in LA. And then we have this big cyclone that's displacing people. And then there's this little one about, climate change putting your morning coffee at risk. So every part of our life is definitely affected, and we know this. And I think right now it's really overwhelming, right? It's like, what do we do about it? It's happening now. There's this big, it feels really globalized, right? It's this huge problem. How do we solve it? So I just want to take a second and tell you a little bit about my own background. I've been working in climate policy officially for 10 years, unofficially for about 15, studying it. And we try to come at these big global problems with big global solutions. We say we're going to tackle transportation, we're going to tackle energy, we're going to tackle waste, we're going to tackle forestry, we're going to solve it all at once in this really big, pretty plan. I made one, it's wonderful, it's at the Department of Environment. They're called Climate Action Plans. And there's a lot of this going on out there. And last year I had the fortunate or unfortunate opportunity of hitting my head and getting 10 months to be off of work and just sit outside and listen to the birds. And in that time period, I thought a lot about, what's the most important thing we can really do? What's the most important thing I can really do? And how can we really affect this change? So if I could, do I have the slides here? I think so. Okay, so Margaret Mead has this wonderful quote. You guys probably all know it. Never doubt that a small group of determined people can change the world. In fact, that's the only thing that ever does. So I want to introduce you today, those of you who don't know, to this small group of determined people that I think are going to change the world. This is the Marin Carbon Project. This is a group of the original scientists out of UC Berkeley and the farmers and ranchers, land trusts, and regional conservation districts that worked to do this awesome new science. And for those of you who haven't heard, we have new news, and it's good news. And it's really great news. In fact, soils can be carbon sinks. So I'm going to go over the science with you really quickly. A little bit of background. When they started this project, there was a couple things they were looking at, and it really all stemmed from the question, can my grazing management, some ranchers up in Marin asked, can my grazing management actually really solve for climate change? And there's a couple questions that they looked at. The big ones were, well, rangelands are the largest cover type on Earth, and land management is the second largest source of emissions globally. So maybe these two things are a problem and can be a solution together. So these ranchers, John Wick and Peggy Rathmann, specifically said, we're going to test this. We're going to do something that no one has ever done. We're going to look at carbon in the soil throughout the levels of the soil. These are test plots on their ranch. And they did one test plot, one control plot, one test plot, one control plot. And over 5 years, they measured the effects of a compost application on their rangeland. And what they found, you can see in this graph, is that organic amendments increased system carbon storage. So a one-time application of compost kick-started a change in the soil system, which created an ongoing carbon sink every year after that one time. We have 5 years of data. Every year we've seen a ton of carbon, net carbon, come into the soil system. So here it is. Here's your control plots versus plots that have compost on them. They bracketed this. They did it in the Sierra foothills, and they did it on the coasts up in Marin. So we know that rangelands in California with a compost application have the potential to become large carbon sinks. The great news is also that plant production increased every year, right? That's what's causing this carbon sequestration, is increased photosynthetic capacity in these plants, pulling the carbon from their leaves down into the roots. This is great news for people who are concerned about climate change. It's also great news for farmers who graze their cows and sheep and everything else on these ranches, because this means that we don't have to talk to them about climate change necessarily. We can talk to them about forage yield. We can talk to them about water retention in the soil. There are a cascade of benefits throughout the system. So the big idea that I want to give you guys some perspective on here is that photosynthesis is actually, I think, the most powerful tool we have in the fight against climate change. And there's a lot of talk about carbon capture and carbon storage and carbon sequestration. And as far as I know, none of those technologies actually work over more than 5 or 10 years. We see carbon leaking back at the systems. They're expensive technologies, but we actually already have the technology that we need to pull carbon out of the atmosphere, and that's photosynthesis. So how powerful is this tool? Well, I've been thinking a lot about it, and something really interesting came out from NASA. I don't know, maybe it was over the summer, I can't remember exactly, but about half the carbon dioxide that we emit from the fossil fuels that we burn every year and goes into the atmosphere, and the other half is absorbed by plants. So plants are already helping us. Plants in the ocean, plants on the land deal with this problem. Just to illustrate this, they've colored the carbon in red. Did anybody see this YouTube video that NASA put out? Right, so a couple people in this room. So what really struck me on this was that here's our atmospheric carbon emissions in the wintertime in the northern hemisphere, and here they are in the summertime, in the northern hemisphere. Just look at this again. Okay, so this is what we're putting out every year. We didn't stop. It's not like it's summer and we no longer drive our cars, right? It's not like it's summer and we all of a sudden switch to renewable power. What happens is that the plants grow in the summer months in the northern hemisphere, and they have a huge uptake of the carbon dioxide in the atmosphere. So I just wanted to give you guys a little bit of perspective on that. So when we look at plant bodies, trees, oceans, and soils, I think we begin to look at the solution that we need to be supporting in this. So this is my attempt to understand how the carbon cycle works. I had to draw it out for myself because, you know, there's a lot going on. There's a lot of different pieces. There are 5 major carbon pools on our planet. And basically, the main thing that I want to point out to you is there's a blue 30 over there in the corner. And then there's this blue 365 here. And that's carbon that we've lost, 365 petagrams of carbon that we've lost from putting fossil fuels that were in the ground into the air. And then 30 petagrams over here has actually been lost from agriculture, from our soils. So agriculture, even before the Industrial Revolution, was starting to leak soil into the atmosphere by plowing, by tilling. When we break up that soil, when soils erode, we lose carbon into the atmosphere. So I started looking at this and I was like, all right, let's think about total potential here. Like, let's think if we've lost that much carbon and then the oceans down here have absorbed plus 155 petagrams, and the atmosphere has absorbed plus 240, the big question for me is, can we use this incredible technology that's photosynthesis in our soils to pull that 240 petagrams out of the atmosphere and put it back in the soil, right? We definitely have to stop these other reserves over here from going up into the atmosphere to begin with, and that's renewable energy, sustainable transportation, and dealing correctly with our waste. But the big question is, can we move that out of the atmosphere into the ground? Well, we believe with the Carbon Cycle Institute and the Marin Carbon Project that agriculture actually can do that. So I'm going to hurry up here and get through this. But agriculture is the only sector right now that has the potential to change from a net emitter of emissions to a net sequestration for emissions. So there's a little bit of that and how that goes. I'm just going to skip over that. But I was asked a little to talk about, well, how do you do this? And there's a couple of different ways that we're doing it. The primary way is we're working with the USDA on something called carbon farming. And carbon farming looks at all the different ways that you can use your farm or your rangelands to sequester carbon into the soil. Now, what's really, really, really key in all of this is this right here, compost, right? That's what you guys all do. That's why I'm here today. And that's what we need a whole lot more of. Okay, that's my presentation. Questions? Anybody?
You don't just need more compost. You need more compost supplied to the land.
That's right. But we need a lot more compost made also. So compost is great on both sides. We remove organics from the landfill, or we take manure that's sitting in dairy ponds creating giant methane bubbles, and we change those sources of emissions into something that when applied to land has the potential to make it a sink. So we need more compost is an oversimplified statement saying we need more feedstocks going into compost, we need more compost created, and we need to get more compost out on the land. Jesse?
So you touched on carbon dioxide, but does this do anything for methane, which has a higher traffic potential?
So the methane benefits really come on the front end, like I said, when you're in how you manage your organic stream. So in the decomposition process, we're really looking at if you can get it out of all these places where methane is being emitted, then you have a really immediate short-term benefit of mitigating those methane emissions, and then you have the long-term carbon sequestration benefit when you get it out on the land. Gentleman in the back.
Has there been any research on the cost-benefit analysis of this? So in other words, there's a first cost to put that compost out.
Yeah.
And what would be like the break-even point or something that can scale?
Yeah, so in order to do the compost application ranges from $300 to $600 per acre. It's pretty expensive right now. What we're trying to do is get incentives in place for people so that compost can be covered through the Farm Bill, through other NRCS practices, and also there's a carbon protocol that was approved by the Air Districts, CAPCOA for CEQA mitigation, and the American Carbon Registry. So cost is really the issue. We're trying to find lots of ways to bring that down. But you do really need to have that upfront capital to get the compost out on your land. However, what we're seeing with increased hay prices due to the drought, that farmers or ranchers who are looking at bringing in hay, if they're looking at 50% increased forage production post-compost application, that actually pays for itself in the cost of hay in the next 2 years. So we're also beginning to communicate with them on that basis of, well, what are you paying for right now, and how can you maybe switch that funding around in what you're looking at?
All right, we got time for one more. Who's got the further one? Let's go across the room.
Isn't it true that it's only a carbon sink when it's no-till agriculture?
Yeah, that's correct.
So proper management, education of agriculture is pretty really important, right?
Yeah, and so specifically, we started with rangeland systems, right? And we didn't go into row cropping, but anything, there's a lot that comes off of rangelands, dairy, meat, wool, cotton. There's lots of different rangelands or no-till agriculture that this can be applicable for, stuff like vineyards, things where you can have cover crops. So it's not all agriculture everywhere. I mean, plowing breaks the soil. You're losing your carbon when you do that. But even applying compost in those systems instead of chemical fertilizers does have an emissions benefit. We're just not sure what the science is on that yet. But yes, this needs to go on land that's not being turned over. Okay.